everything about this project, it wouldn't have been a success if it wasn't through collaboration, through our owner, the YMCA, architects and interior designers at my firm C Design, the structural engineer at Fitzpatrick Engineering, and then also Galleon Timbers was our glulam and heavy timber fabricator. So there was design and feedback the whole way through. So let's just go ahead and get started. This project was completed in 2013. It's the YMCA Pavilion at Camp Harrison, who we are. Been with C Design for a little while. C Design's founded in 2003, 20-person firm, and really we have about 5 major specialties: operations, transportation, education, workplace. This would be one of those: recreation, and it's really one of the more fun project types. You get to be with fun clients, whether it's Parks and Rec, YMCA's. There's a ton, but it's a lot of fun, and it's always great to see people actually occupy your space and have a great time in it. So if you want. All right, so just a quick little background on Camp Harrison. Camp Harrison is in Boomer, North Carolina. Doubt anybody has been there or even knows of it. It's a pretty small town near Wilkesboro, North Carolina. So this YMCA is a summer camp primarily, founded by the YMCA of Greater Charlotte. It originated from a desire to offer a unique venue for youth that would build upon the success of the nationally recognized Camp Thunderbird. And Camp Thunderbird's in Lake Wiley, really actually not too far away from the case study that we saw earlier in Fort Mill. But they had a ton of success there, wanted this a very similar venue up north in North Carolina. So this was kind of the finished product of that. The Ridge, as it's called, opened its doors in 1996. In 2015, Camp Harrison had 1,800 campers in the summer and 10,000 guests per year. So it's really grown pretty fast. Just kind of going through the camp vernacular and what's already there on camp. Right now, I mean, I think there's 2,000 acres of land there, largely forested. So it's got a man-made lake, plenty of mountains to go hiking in, and really travel around. There's horse stables, there's dirt bike, paintball. I mean, just about everything. It's really fun camp, actually. But right here, what you see in this image above me is the main round where all the cabins are. And this is really what most of the structures on camp really look like. It's largely log construction for these cabins. So it's got more of a cherry look, cherry finish to the logs. Then there's the green stainless steel, green standing seam metal roof. That's consistent throughout the camp. We didn't want to venture too far away from there. So just keep that in mind when you are really seeing the finished product here in a couple minutes. This is the dining hall, and then another view on the left of the front porch of those camps. That'll also come into play. So as we were talking earlier about how Camp Harrison started from Camp Thunderbird, this is an image of a pavilion that we C Design completed at Camp Thunderbird, really the exact same program, but we completed this about 5 years prior. So this was really the start of this project, our pavilion that we're showing today. Just wanted to show you this also as a backdrop. We do consider it a success, but we definitely learned some things. And the YMCA learned some things about how they operate and what they need as far as this type of facility. Mainly, it's an open recreation area that you can have basketball. You can see the goals in the picture, and then as well volleyball. So starting off, here's an image of a Google image of Camp Harrison. Here's the entry right off the highway. You kind of whip around and enter in, excuse me. Here's the main entry. That's kind of the back entry I just showed you. You have the lake right next to you as you come in, and you wind around until you get to really, here's where that loop of cabins and pool and dining hall is. Our site is just down from there. So as you can see, this is kind of a zoomed in version of this. This is our building right here. So it's really located right, because it was a recreation building, they wanted to locate us right in the middle of all these fields. It wanted to be a space for covered recreation, a place that was also, you know, if you're playing soccer, you can go into this space, get this covered area, get out of the elements. But then they also just wanted another place that they could escape the rain as well. So one thing to know, the main access, unless if you're coming by car, from the cabins is down this little path that comes through the woods and into our structure. So one of, as we're going through this, keep this in mind, there's this kind of feeling of compression that you go through these forests. You really can't see the views beyond. So we wanted to really put most of our structure in here and kind of compress you through these two little openings to this expansive view beyond and the fields beyond. What was a pleasant surprise about the whole thing is halfway through construction, they started creating a zip line that went from over here and zipped all the way to the base of our pavilion. So that is a pretty cool thing. I mean, not a way that I normally experience my buildings going, 10 miles an hour through the air to the base of it, but that was kind of a nice little surprise at the end. But beautiful landscape, beautiful views. The program, just going straight into it, as I mentioned earlier, it is an open air pavilion. They wanted as much natural light as possible. Camp Thunderbird, as you saw earlier, is very open. It's really just a shed on top of an exterior slab for a basketball court. So they wanted, we ended up with about 8,000 square feet of occupiable space. However, it was really, we were given a construction budget and said, what can we do with this? With the YMCA, we're always slightly hindered by the cost of the project. The budget is always a number we're trying to fight because the Y's wants are always a little bit beyond what they can pay, just because it's donated money. So from the very get-go, we were really trying to work with them, see how we could cut our costs to get the most square footage for this building and really get the most use out of it. And also another piece, it not only was an open air pavilion, but one important thing was flexibility in our floor plan. They wanted to open this up so you can play basketball in here. There's posts for volleyball that you can, the kids can play, and really just they also wanted areas that for if it's raining, people can come down here and just have story time or whatever really they desire to kind of just play it by ear. Even receptions if needed. They've used this as event space as well. So the other thing that kind of had us scratching our heads was the YMCA came to us and said, we love Thunderbird, thank you so much for it, but we want to be protected from the rain. So we want this open air pavilion that's completely wide open, but we don't want rain to hit us. So that was this kind of back and forth of trying to manage how do we keep this open, let natural light in, but close it off enough that we don't have to worry that this can still be occupied space during a rainstorm. So, and we can get into some of our strategies into that later. The overall cost of this project was $880,000 for it being an 8,000 square foot. The cost per square foot is $100, $110 per square foot. Some of the design concepts, main design concept is kind of a cliche in the architecture world, but it really kind of drew inspiration from a cocktail sketch that came from just a lunch that me and the principal at Sea Design, Rob Crane, had at just over lunch at Dilworth Grill here in Charlotte. So it's kind of amazing to look back at that earlier sketch that we have here in this next slide and really see the resemblance from that first sketch to the final product. So one of the things was maximizing those views. We drew inspiration from horse stables on site, just referencing the camp's active equestrian program. So there's many goals and opportunities. One was to maintain that camp vernacular. We loved the wood. We loved that log construction, but we wanted to go lighter with it. We wanted to keep with that vernacular, that look. Oh, by the way, this at the top is that first sketch that we did. We wanted to keep with that look of wood, but kind of push it into being something a little bit more special, a little bit unique. So we did that through glue lam and heavy timber construction. We wanted to frame views to the landscape, maximize views to the mountains beyond. So this is a section cut through the building. This would be, you're coming from the cabins down into this hill, through this back, if you look here, through the, right next to where the toilet rooms are. This is kind of just this bar of solid program that you have to enter through to get to this main open space. So you have a lowered ceiling here. This is all stick-built construction for this back bar. And it's really kind of a building within a building, just nestled underneath the big sloping roof. So this sloping roof did several things for us. It not only was this kind of grand gesture out to the mountains that allowed view out, it opened up. We couldn't afford, getting back to the costs, we decided at an early point we couldn't afford to do a full-size basketball court. That was something that if we could, it just couldn't be the type of building that we wanted. So what we decided to do, and you can see in this last slide, is create a half-size high school court. So we wanted to keep the dimensions of the court the same, but only to do a half-size court. That saved us considerable costs right off the bat. But the other thing that this single slope roof does is if you imagine someone at the three-point line shooting their basket, it kind of follows the arc of that shot. So that was also one design, as well as it was opening up to, going back one more time, this plan north is true north. So all of our light is really coming from this natural ambient northern light. And then we have skylights that allowed translucent light in through there. Also, just speaking of just kind of natural ways that you orient your building, we oriented it east-west in the long direction just to get those cross winds and get natural ventilation through there. Again, natural light, natural ventilation. We wanted this to only, the YMCA to only have to turn on the lights at night. We wanted this to be a light-filled space and just ready to be occupied. Some constraints was maximizing the square footage within the limited budget. One of those things was the half court versus full court basketball. And then we also played with the structural bays and the number of them to see how large this space needs to be. And then I mentioned as well maintaining a feeling of openness, but stopping rainfall from entering the building. This is an early sketch that we had. One idea was, as you saw in the that main section, our main volume of space is really in this high bay right here with the single roof back. What we wanted to do was create a front porch that was similar to the cabins that are already on site. That would really lower the scale of the building. In order to get that great space and enough room to play basketball, we really had to create this structure that almost seemed too big for the site. So by creating this, this porch that wraps 3 sides of the building, it really was able to bring that scale down a little bit, as well to just block rainfall, and then just provide a covered entry, as well as, I mean, the front porch is something that is everywhere in most of the Carolinas, but especially Boomer, North Carolina. So here's just a diagram of how this was constructed, of this main space that's with glulam construction. Doug's going to really go into that a little bit more. They have this single slope roof that gets put on that, and then this front porch that has this wooden screen that wraps around, which will stop that rainfall from coming in, but also still allow views and natural light into that space. But why use wood? It was probably the easiest decision in this whole design, not only for the reasons of sustainability and just this being a natural resource, a renewable resource, but really from just an aesthetic standpoint, it was a common sense decision for us. Not only is everything on that site of wood or log construction, but so we wanted to enhance that or reinforce that vernacular, but also it's just a beautiful product. It's warm, it's welcoming, people go in there, and the architecture almost goes away when you're enveloped in this wood building. So, I mean, it's almost like the architect's cheat sheet, that you can just throw wood on the inside, on the exterior, and people are going to just fall in love with it. So, it also provides, I mean, this, as you saw, it's in a mountainous area, provides continuity with those natural elements surrounding. All of the wood was southern yellow pine. There's glulam, heavy timber, stick frame construction in the back. The design of the pavilion, as I mentioned earlier, resembles some horse stables that are on site as well.
9 times out of 10, the buildings we built with other materials, it's the first thing to go up and the first thing to get covered up. So nobody ever gets to see really what we get to do, our part of the work. They're glad that it's there, and the buildings don't fall down, but nobody really ever gets to see it. But when we get to do a building like this one, structure's exposed, and we get to see all of our good work. So if you'll indulge me for a few minutes, we'll talk a little bit of structures. I won't bore you with formulas and equations and all that kind of stuff, but there were some interesting little challenges that we had to deal with on this one. So for an order of magnitude, the building's about 110 feet wide and 75 feet deep. There's the main centerpiece that was the basketball court. You had the kind of the utilitarian stuff in the back, and then the breezeway around the perimeter. So from a framing standpoint, it was all relatively simple. We had this high roof, single slope. It's about 30 feet tall in the front, about 18 feet tall in the back. Dean had mentioned there were some skylights. The main framing ran front to back of the building. It was 12 1/4 by 28 7/8 glulams. That was the accent pieces for the main framing. Then we had 5.5 by 11-inch glulams that made up the purlins. And then the roof decking, which was exposed underneath, was 2 by tongue and groove decking. So pretty straightforward. Cantilevered over the low roof a little bit, just for visual purposes. Then there was the low roof framing, which over the breezeway tried to mirror the structure that was going on in the main roof of the pavilion. So we had this main girders running in the same direction up and down the page. They were 8 by 8 heavy timber, and then we had 3 by 6 7/8 glulam purlins, and the same 2 by decking, tongue and groove decking that made up the roof. Everything was generally on a 9-foot grid. There's some places where it was 18 feet, but generally 9-foot grid. And then in the back was kind of stick framed over the bathrooms and the storage areas. So the challenge for us on this one was, if you're kind of connecting the dots, open view in the front and on the sides to let air in, and this utilitarian area in the back, doesn't lend itself very well to nice brace frames or something on both sides of the building in both directions. So we had a main shear wall that we could use at the front of the bathrooms, and we had 2 shear walls out on the outside, but you can tell from the picture this whole thing's off-centered. And although we're not in Charleston, we do have to deal with seismic in North Carolina as well. And when you have all the mass out in the front of the building and all the stability in the back of the building, that creates some problems. So, of course, our first choice would have been a couple nice big brace frames or shear walls right in the front of the building to kind of make 2 frames this way and 2 frames this way, but that didn't go over too well with the architect for obvious reasons. So, it had to be open underneath, so brace frames going to the ground was a problem, even if we tried to do something light like rod bracing like you have in here, but it needed to be open and free so the kids couldn't run into these kinds of things. So we started toying with some different ideas. Even though shear walls are rigid by definition as opposed to something like a moment frame, they still do have some flexibility. So what we looked at trying to do was balance what rotation we thought we were going to get due to all these off-centered loads, and see if we couldn't come up with a way to make something in the front that was stiff enough that it would actually take some load and not move too much and have all the load go back where we didn't want it to go. So first thought would be rigid frame, nobody wants braces. Keep in mind that the view is out to the front, and for rigid frames to do a lot of work, you want the stiffness in the direction that the load is, which means we'd want our columns to be really wide and skinny, which is now blocking the view out to the front of the rest of the campus down the hill. So that wasn't going to work, so we had to figure out a way that we could turn the columns the weak axis and still try to get enough stiffness. The members, and have a few of them that were participating in the stability at the front, all of a sudden the connections start getting large, or the numbers start getting large to deal with, and maybe to the point of where they're architecturally unappealing. So the idea was to engage as much of the material that was there, try to keep it as small as possible so it satisfied the architectural need for having to have an open view out to the front without getting too obstructive. So we ended up with our main columns there on the column grids. The round dots on the bottom were moment connections at the base of the wood. And then we came up with this idea of having rod bracing so it was unobtrusive, but something up just above where people would be walking so that it would add some stiffness to the bottom part of the frame and let our columns do a lot more work structurally. And then up at the top, we still had to get all the way up to the 30 feet. We looked at engaging all of the headers and sills of the windows that were up above to get some rigidity from that. And that's basically what we ended up. You can see the numbers here on the right are actually pretty small to work with. What was really helpful was we work with Galleon as sort of a designated engineer, if you will, to help kind of work through all of the connections here. So one of the challenges, after we solved that problem, then we weren't really sure how we were going to get the moment connection at the bottom. We didn't want to have big clunky base plates or anchor bolts or angles or tripping hazards for all the kids that were going to be playing in this area. So our first concept was the one in the upper right-hand corner where we kind of embedded a tube shape into a footing, and it had that stubbed up that they could then sit the glue lam columns over top of it and bolt through it and get our moment connection that way. Once Galleon got on board, it actually morphed into this final detail on the left, which was more like a traditional footing. There were some construction sequencing things that the Y had kind of requested about how they wanted the slab to be poured and how they wanted it to look. And it didn't lend itself to being able to do it like we thought we could in the first one. So we ended up having an individual footing that could be in place with some other material in place that we won't mention, that then the column could slip over. So they actually routed out the inside of the glue lam to match the shape of this other material that we had in the foundation, and then through bolted it to get their moment connection at the bottom. It was actually a very clever solution that Galleon helped us work through. So, and they handled all of the connection design on all of this. I just was going to show a couple images from their shop drawings that we reviewed and worked through. This is kind of a general, their model of looking at that front elevation. You can see how it's all open underneath. They have the rod bracing in place, and they had some high windows that had a header and a sill underneath it. This is kind of a section through one of the side walls where you had the low breezeway roof in the same line with the first main structural girder, purlins on top. So some of the connections they worked through. So where the main glue lamb framing members in the pavilion, the main open pavilion part of it, cantilevered out past the main part of the building. You know, they had worked out all these connections for us and specialty plates for all those connections. They helped us work through the details of how to get these rod braces connected in the corners. You can kind of see how they're all through bolted through. Maybe you can see, but the angles are through bolted through, and then the rod bracing was welded off to the a gusset plate, if you will, in the corners with the clip angles. Nice, elegant, simple little solution that helped transfer the load through to another member on the other side of the wood instead of trying to do it with lag bolts, which would have been a lot more material and not as elegant looking. And then finally, these are some of the photos from construction. This, I guess, is on the left-hand side, the west-hand side of the plan. I think that's right, yeah, with the breezeway going up, and then the beginnings of the front brace frame. Just more pictures through there. This is a distance. They have the whole high roof portion on and working on the low roof over the breezeway.
This is the first view that you have of a built structure on the whole camp. So you know, if you remember that site plan, you're kind of winding around, and then finally it opens up, and this is kind of that first view. So you can see that not only does that roof kind of slope up for all the views, but it's also, it kind of slopes up for that first impression at the site.
Pretty close to the one on the lower right. They're getting the just about closed in on the back there. That's pretty close to being finished, I think.
Right.
So you can see all the windows up high to get light in. You can see the skylights, just barely, underneath the pavilion there in the back, underneath the high roof that's letting light in.
This is something that we were really focused around. This is the portico or the breezeway, the porch. It has like 18 different names for this project, but we wanted to keep it as open as possible, but still protect it from the rain. So what we came up with, and there was so many different designs for this, but we ended up with this one, which is very simple, but it seemed to work best for us. It's this wood screen, which is basically built like a wood pallet. So, you know, 1-bys slats on either side that, you know, have a space in between with just 2-bys in between to hold it up. Very simple, but it still lets those views out, but blocks the rain coming in. Or, well, you can never fully block it, but as much as we could. One thing we wanted to do was also, we kind of drew inspiration from those horse stables. They had these sliding barn doors. So we wanted to incorporate that somehow, and that'd be that extra ability to close off this as needed during rainstorms. But same type of screening that we had on that. I think, so here's one view of it. So you can see the wood slats beyond, and then these are actually 4 different barn doors that pocket back into this space right here. So they kind of go side by side, so all 4 of those can fit back within this space. Really, this is the siding before the stain was applied, and then on the back side, this is where the stain was applied. We decided to do a colored stain just to have reflect the other structures on the site a little bit more. What was done before that staining, however, we wanted to make sure that this building lasts more than a year. So we made sure that all of the heavy timber, the glue lambs, had a boracare treatment on it, which just for termite protection, and then a stain was applied after the fact. All right, so one thing that we thought was kind of just it was really one of the last decisions that we made, but was what do we do to keep birds and everything out in between these purlins? And what we originally had was just the same size purlin that goes up above that main glue lamb member and blocks that area off so nothing can get in. We decided at the end to just, I mean, it's almost like chicken wire, just to block any birds or anything from nesting up there. But what we were just very pleasantly surprised about and happy with is that it just gets this, if we blocked that off, we wouldn't get this nice little glow from underneath. It really let light out at the nighttime shots and just create this beautiful glow. So, here's the finished product. Just so you can see how we wanted this portico to be that kind of first barrier to the elements and this space to overflow out into. I was looking on just some Google images before we got here, and apparently they've had some wedding receptions out there, so which I was very happy to see. But you can see this screening that wraps around all sides, and you can also see, you can imagine if this front porch wasn't there, that this front would just seem a little bit too large. So that really brings that scale back down. I learned something today with the earlier presentation about a better way to do these end caps. So this day has been very fruitful for me. So we're probably going to use that going forward, steal that detail. So again, the clear story windows just lets a little bit more of that natural northern light in. Here's a view to the kind of through the porch out to the zip line, which ends right here. Just kind of a cool little shot for you. You can start to see really how you have your main glue lamb columns every 18 feet. In between, you have that heavy timber construction that wraps around. Again, you let some of that nice light through. You can see the shadow work that's kind of coming through.
So the question is, what percentage of the construction cost of the $880,000 was the wood material?
So I was actually looking back earlier today just because I knew my brain can't reach back 4 years with that kind of information. But the Gallion's base bid with the treatment of solid timbers was $271,000. That's delivered to the site. So adding the galvanized hardware was about $8,000, and then adding the stain was roughly $9,000, plus the boracare for an additional $16,000. So I mean, we're looking around $300,000. Just for the wood component? Yes. So, and one of the great things that's kind of been mentioned earlier is it's just wonderful that for a project, I mean, just speaking of the beauty of the project, but also constructability and just the cost, the fact that that wood can serve structurally as well as a finished material is amazing in many aspects.
How important or how, when you're doing one of these kind of buildings that has a lot of blue lamb and heavy timbers in it, is to pick that manufacturing firm early to work with you?
So,
or I think that's what I heard you say. You worked with them, or how did you go about choosing?
Did this wood come from Georgia or Alabama?
oh, that's a good question.
I have no idea.
I want to say Georgia, but I can't say for sure. What was great about this, and I'll let Doug has a better grasp of that than I do. But what's great is that we worked with Galleon Timbers in that Camp Thunderbird project. We had a relation with them, and we bounced ideas off of them in the early stages. One of which was, how long can we actually get these Glue-Lam members to come to our site from, Georgia, Alabama, wherever they are. So part of the main spans were, the length of that was kind of limited by the shipping requirements. So that's one thing that we kept in the back of our heads and kind of like kept us within this certain zone, that kind of sweet spot of where we could do it. As far as the true design of the details, I mean, they gave us guidelines during design, but you want to talk about
It wasn't until we got into shop drawings is when the rubber kind of met the road as far as the final connection design went. And there was some balancing back and forth of how all that stuff was done, but generally that was done during the shop drawing phase for their stuff.
And there's also some work, even before the shop drawing phase, of once the bids came in, we started kind of our value engineering process of are there things that we can kind of tighten this a little bit. So there was some discussion with them about certain things, and that was actually one of the things that they helped guide us on was what the treatment should be for termite protection. So we were going between several products. One, we ended up with Boracare. One that we did at Thunderbird was Copper Azul. I can't remember exactly, but what? There you go.
Easy for him to say.
Okay. Yes, thank you. So one of the things that hindered us on that was not only schedule, because that had to be shipped, treated in some cylinder, but it was also that because due to the length of our members, it could only be done in like Minnesota. So the cost to ship everything out there, ship it back, and I mean, it just really added a lot of costs that we just couldn't take on. So there was some, we finally went with that Boracare product, but Galleon was very instrumental in that. So here's a shot of the interior. This basketball goal will kind of rise up into the rafters a little bit, open up, and then we have our volleyball posts that you can't see here, but are right in the middle. This back part being low also helped out because they wanted the freedom to have a stage there as well. Unlike the earlier case study, we didn't get wood fans in there, but we do have our big fans.
What kind of lighting?
We went for, even though they look like metal halides, it's an LED light. So one of the things was, that was one thing we pushed for not VEing out, because in order to get a boom lift or scissor lift or whatever you need to get out there to actually fix those, we knew we needed these lights to last 10 to 15 years, or else they're just not going to have lights in certain areas. So we did decide to go LED. Here's some more details of kind of the corner where these Glue-Lams are being the heavy timber, some of the connection details right there. And then kind of final camp photos of these kids playing. And so want to say thank you again to the YMCA. David E. Looper was the contractor. They're from Hickory, North Carolina. Obviously Fitzpatrick Engineering, and then Galleon Timber as well. Again, open to any questions, but we've got our contact info right here. I'll leave my business cards with Pat, so if anybody wants to reach out afterwards, has any additional questions, or just wants to see some more images, just let me know. But well, thank you.
Okay.